Okay, hello everyone. Welcome to another Wolfram language design session, incremental language development, a variety of topics, HeadMap and the naming of it. So, HeadMap is something that will take a
list of heads and apply each of them to a result, to an input and give you the list of results. So it's sort of like thread only rather than giving, FG of X, list FG of X and thread that, you give it the list FG and then X.
Do you mean through Itai?
Yeah, through rather than thread.
Yes,
Yeah.
through. I misspoke.
Okay. I mean, this function, every single time I hear its name, I don't know what the hell it does. So possible names. Let's go down here again. Why do we think it should have the word head in the name?
Because map normally takes a head and arguments and applies the head to all the arguments. This is going to take several heads and apply the heads to a single argument. But you could maybe call it a function instead of a head, but function map is a little bit vague.
Yeah, it's
What
too
about
vague.
map heads?
I think it would, what I would think that meant was map onto the heads.
I see.
Right, like map all maps to everything. And maps at, right.
Through applied. Would through applied make sense?
I think we talked about this last time. I think it just compounds the bad name that is through.
I mean, there's also the question of if it's var args or if you wrap the arguments in a list and you have a level spec. If you wrap them in a list, then applied makes more sense. If you don't, it's var args and applied is less. Right.
Or if you just require that people use apply, the headdress apply if they want to,
Right. But
why isn't this thing
a
ahead? Why isn't this thing something? Why isn't it something like this?
That is one of the suggestions you have there.
Oh God, we already had it there. Okay.
No, but also I think applied makes it sound like one of these sort of, combinator operator applied kind of things, which, this is not exclusively. In fact, I think this would be more useful not in that context.
To explain? I mean, you mean as a,
like you keep writing this as an operator form, but I think that it'll be used more in its non-operator form. Like both will be useful, but this is not at all like we have these functions that are like they mostly live as operator forms, and then we have functions that just so happen to have an operator form. This is the second category.
Right, and also notice that right, it's right, it's sort of skipping part of the list there, right? All applied would give you the list f of, right, if you literally
f of x g of x. Yeah.
Right. So in that sense, it's sort of a not really in the applied family, which,
Why isn't it in the applied family?
Right, because those take what's inside and use that as a head, and you're going to break this up and use elements of it as a head.
Fair point. Okay, again, what is this thing really? It's taking
I mean, the case I imagine using, or that I've done something similar to this, where I occasionally use through, is I have a data set and I want the mean, the median, the commonest, the variance, etc. I want to apply a number of functions to the same set of data. So I sort of think of it as a multi-function, but that name probably has other baggage.
It has other things we're about to do with it.
Yeah.
I mean, that's one usage. Another one that data set actually does automatically, but which is useful outside of data sets if you have a composition chain, and in the middle of the composition chain, you want to apply 2 functions instead of 1. So data set already does that automatically. If you put a list in the middle of a composition chain in a query in a data set, it will apply both functions and return them as a list. But right now, if you outside of a data set, you have to use through to do that in a very
Okay, so
exotic
what are you
way.
saying? So you're saying something like this head map GH.
Exactly. Yeah, compose something else. Right.
Okay, and so now
So
I
what that
apply
will be
this.
is,
All right, does this, okay, so if I now apply
Yeah.
this to X.
Right.
That's cool. That's really cool.
that's a super useful operation if
Although in an operator form.
that is the operator form. Yeah.
No, I know, but it's
But-
going to, this name head map is just completely not making it. Every time I look at it, I don't know what it means. Okay, what is this thing doing? It is, and how does it relate
I think
to?
it's like an evaluate list or an evaluate each. I mean, I suppose we could go with apply list or apply each, but it's right. It's not apply in the sense of apply.
Yes.
It's more or
Is Nick here, by the way? I think is Nick here because is this in fact a multifunction?
Both Nicks are here, yes.
Oh, okay. Then Nick without the C.
In what sense it's multiple? Because it has
Well, I mean,
multiple functions.
I don't know. I mean, this reminds me of a monoidal category type story. Like
I mean,
this
it's
is
just
like,
it's a multi-way in the sense that it's applying all the functions you gave it. Sure.
yeah.
right. So the thing that takes f and x and gives you f of x, that's operate, correct? Or am I
Takes what f
Wait.
of f and
There's
it's construct.
Construct takes
yes.
f and x, and yeah.
Right. So should this be like construct list or construct each?
Well, so one of the questions we had last time, although I think we were generally leaning away from this, was so with construct, if you say construct of f comma x comma y, it's going to run f of x comma y. And so one of the ideas with the head map thing was that normally with lists, the third argument is a level spec, but an alternative would be to make head map varargs, and it'll kind of do something like what construct does. But I think we were moving away from that because I think there was one, it seemed like slightly weird behavior that you can easily get in other ways, and two, the level spec is a coherent thing to have for head map, and so it, yeah.
Yeah, I don't think the varargs version is particularly important, he says. Although, I mean, in this chain, no, because in
How would
the
you
composition, composition
just takes
allow,
one argument things generally, unless it's the last thing in the composition.
right?
doesn't
I
really
mean,
make
by the way,
sense.
all this stuff like Jonathan's category theory stuff is, in a sense, potentially, if I'm not, I mean, the monoidal category stuff, I think, is a way in the string diagrams. Am I right that string diagrams are related to being able to do multi-argument versions of composition chains?
I mean,
Anybody
isn't
have
it
a
basically just you have this thing that just tells you which arguments go into which other arguments?
Yes.
I mean, which ports go into, yeah, right.
So in a sense, one of the things we could imagine is something like NetGraph.
Well, but by the way, I mean, this is otherwise, I mean, in programming, you represent the same concepts with like variables and function application.
Sure. Well,
So
except
it's like, this isn't really I think there are existing ways to do that.
no, I understand. But the point about it is the concept of a disembodied, variable mapping, a disembodied graph into which you feed functions, so to speak. So imagine that you have, which is similar to the currying business. Curry is another disembodied meta, sort of pure bureaucracy, pure routing function.
you could easily have a function that you'd call, I don't know what exactly you'd call it, but it's like a version of composition where you give it two functions and then you give it a permutation, and it'll use that permutation to map the outputs of one function to the inputs of the next, or something like that.
Well, assuming that functions return lists.
Well, or anything you can take parts from, but that's a lot of things.
Yeah. But so, okay. So this is knitting together functions that take lists as input and give lists as output.
Well, I thought the idea is they take, well, I was imagining as they take sort of n arguments as input, and then the other one returns something, containing n elements or n.
I agree, but the problem is that we have a way of representing, the way of giving n arguments is different from the way of listing n things in output. And I think it would be simpler to make it symmetrical. I mean,
but then that's just equivalent to having composition where in the middle of the composition you have extract. It's just F compose extract compose G.
Well, unless you have a thing where you can skip a function. See what I'm saying? You're right. If it's a series of blocks that are one after another, but if you go,
I think if you're skipping a function, it's going to be so complicated. Like this is really just use variables. Like that's
well, no. But
that's exactly what variables specify.
I know, but the whole point is that we want to be able to do. This is the whole point of this, monoidal categories, net graph, et cetera. And I think it's in string diagrams, I believe, if I'm not wrong, this is this, can somebody confirm this is related to string diagrams?
Well, it is. If you're skipping a function in the string diagrams, it essentially means you're using an identity box or process, whatever you want to call it. Right?
Okay.
If you're composing a function that has two outputs and with a function that has only a single input, it's equivalent as you have to have this function product, horizontal product with identity, right? So that you ignore one of the outputs.
How does this relate to what you've done in the quantum framework?
Because that's the same thing you do with tensors. You have tensors have inputs and outputs. It's covariant, contravariant, and indices.
Yes.
And you can represent it with string diagrams.
But in our case, okay, how do we have? I mean, so this idea of the pure sort of knitting together of inputs and outputs of functions, what I'm imagining is a little bit like, I don't know, a graphics complex where you give the knitting and then you give the payloads. Does that make sense? So here you've given the string diagram.
I just think it's a very unnatural way to code these things. I mean, this is why, for example, this is like one of the ideas of TensorFlow. So the way that TensorFlow works is, internally, of course, there ends up being something like a net graph eventually. But with TensorFlow, the whole idea is that you just call functions, and then this will kind of construct, in the background, this kind of constructs this graph. But I think just the fact that that's just an example of where, if you're doing stuff where you're using these sort of very small primitive operations, because that's the style that you use in TensorFlow for better or worse, it's very hard to write that in kind of a graph style. It's much easier to just write it as a program.
So we've got two different styles. We've got the, x equals y plus 6, y equals z plus 2, et cetera. And that, that can turn into a graph, right? And that's exactly what happens in something like System Modeler and so on. It's got a bunch of equations and it turns them into a graph, and vice versa. But I believe,
I think thinking about equations is too. This is also the case with generalized functions. But yes.
What do you mean by generalized functions?
You're talking about it in a math context, but like this is the same with anything, right? If you just write a program where you call some function that has 5 outputs in a list, and then you distribute them like that, and et cetera.
No,
et cetera.
I know. But what I'm saying is that just like we're talking about right now, making trace graphs, evaluation graphs, things like that. This is this is the dependency graph. We should be able to go back and forth between a variable specified dependency, a variable specified thing, and the disembodied dependency graph. And my claim is that there are going to be cases where having the disembodied dependency graph, in fact, we could even argue in some bizarre sense that the physics project is a story of basically reducing the universe to a disembodied dependency graph.
But the thing is that generalized programs, I think, I predict that we sort of even with stuff like attributes and things like that there's enough floppiness that actually getting out a dependency graph, a rigid dependency graph, might not always be possible.
Yeah, that I agree that with the actual semantics of the language, that's the case. But what I'm saying is that going the other way around, given a dependency graph, be able to evaluate the dependency graph. I mean, evaluating the dependency graph, it's very similar, I would think, to treefold. Treefold is a specific case of evaluating a rather specific. I mean, that's not quite a dependency graph. That's the, I don't know. It's something related to that. Brad, who can actually speak up in audio, is mentioning directed acyclic evaluate, which is again very related. I agree, directed acyclic evaluate, which is not a great name as we've discussed, but which is the analog of treefold for a DAG.
So I think it's a perfectly fine concept, although I don't think we should design it as though it's sort of a, composition is something that's sort of used in the context of just pure programming. Like it's a programming convenience that you use to make your code look nicer and so on. But I don't think this will be like that. I think this will be much more convoluted than just writing it as a program. But it might have other uses somewhere else.
Okay, so Nick, of course, has already evaluated, has already, implemented some of this. So what on earth is this? I think you've shown this before, and
I've shown it before. It's an old Padlet for string diagrams, and it also can be used for functions, right?
By the way, I've shown a meta point that I have no idea why. Oh, maybe you deployed it so long ago that it doesn't have the thing that has the parenthesis that says.
Yeah, it's like 2 years ago. It's
okay.
like 2 years old.
Well, I think it needs to be brought out of mothballs. I mean, what the heck is that creature?
I like how wiggly the lines are.
Yeah.
Because they're actual vertices, right? Each wiggly line represents a box. So it's also a graph. So it's rendered kind of hackily. You see a wire, but it actually goes for a vertex because there's actually vertexes rendered with wires. That's why it's so wiggly. Well, it's besides the point. I was going to mention the execution. Open the one bullet point above. It's related to execution thing of string diagrams and composition of functions. So you can specify it with tensor notation. You get the string diagram, whatever string diagram you want, but it treats each process as a function, and you can apply it to a list of arguments. If they're horizontally composed, they run in parallel. If they're sequentially composed vertically, then it's sequential execution.
We really should. This is very nice. I mean, this is a pattern that just seems. It seems like we really should be able to use this. I mean, I think it has a little bit of grinding to go before it is understandable. I mean, okay, this composite. So how does this relate to tensor multiplication?
It's directly right. You can even ask for tensor representation for each string diagram. So if you have horizontal composition, it's a tensor product, or more of a Kronecker product. If it's a sequential composition, it's just a dot product. No, usual tensor index contraction.
Yes. There's a big unification here that we should be doing of this thing about disembodiedly routing, inputs, outputs, tensors. Is Jose here? Can Jose comment on
I'm here.
on the-
Yes.
on the tensorness of all of this? I mean,
yes, this makes sense. We have discussed similar things, this birth track rotation. And what I see here is the combination of the contractions and the product in between. So usually we use times, but there could be contractions and other products. Say,
you mean you use times as opposed to Kronecker products?
No, times as opposed to non-commutative multiply. Some other product between the tensors.
Okay, but in ordinary tensor operations,
yep,
what Nick is describing as a Kronecker product, I just take two tensors, T and U, and
yep,
I multiply them in the ordinary sense of multiplication. I'm now getting confused here. That is effectively a Kronecker product. It's T alpha U beta, and T alpha times U beta means the Kronecker product, right?
No, so there are two different things here. One is having an outer product of tensors without indices, and the other thing is using indices to represent the individual components of the tensors, and then using normal times multiplication of those components.
Yeah, exactly. Okay, so T alpha ordinary times U beta is like an outer Kronecker-like product because you've got two different indices there, whereas T and U without indices and index-free notation, you have to decide whether you want the dot product, which will be essentially T alpha, T beta, T alpha, U alpha.
Exactly.
Right.
Yeah.
And so the point is, in the index-free notation, you're saying that you can emulate the stringing together of indices, the knitting together of indices, by giving a string diagram that describes in a quotes index-free way how these different pieces of tensors should be connected together. Is that right?
Yes, it's right. So you don't need any explicit index constructions. You just represent all the linear algebra you want with just string diagrams.
Right. Which is also what happens in the quantum case, et cetera, et cetera, et cetera.
Yeah, right.
So we really should do something with this. We really should make something, because this is, what this is it's a special case of the problem of, graph evaluation, I think. And maybe Brad wants to comment on the relationship between this and directed acyclic evaluate.
Well, one experiment that I tried and failed to do is to even make a graph that describes matrix inversion at an atomistic level of just moving the values in the rows and columns around. So, that's a target problem to solve of something like try to get trace graph to work for inverse of, say a 2x2 or a 3x3 matrix.
Why is that relevant to the string diagrams business? I didn't understand that. Is that I mean, because we can generalize here, because am I correct in believing that in the string diagram, normally you have, oh, I see, these indices, it doesn't matter whether these are, there's no sense of, normally with indices in, tensors and general relativity or something like that, the tensor indices run over successive integer values. But
and here you can have any dimension. So basically you assign a dimension to an index, and that's all that matters. And also maybe a direction.
What do you mean by a dimension? Sorry, I don't understand. So
what do you mean if you have, it's like you're pointing at a tensor that have rank 5 because it have rank 5 arrows. And because if you just look up the dimensions of a tensor, it would be like 5 integers. So we have a dimension assigned to each of the wires there.
Okay, dimension in that sense.
Yeah.
But then that's a tagging of the wires, and the wires better agree in dimension if you connect the wires together, correct?
Yeah. Yep.
I wonder how that will generalize when you don't have interdimensional wires. Different question. Okay.
Right, but connecting the wires together, I don't know anything about these diagrams, so you have to correct me if I'm wrong. Connecting the wires together, is that just going to be some sort of summation process or
Yes.
something like matrix multiplication? Okay,
Yes.
well, matrix multiplication is I think probably easier to represent as a graph calculation than something like the Gauss-Jordan elimination.
Yeah, but I don't understand. Why is you're saying, how do you break down matrix inversion into a series of operations that are essentially just tensor contraction like operations?
Yeah, well, look, let's say you have an 3x3 matrix.
Mhm.
That essentially is 9 inputs that come with some
Yeah, I
sort
get
of
it.
structure.
Yeah.
And then at the end of the calculation, if you inverse it, or even if you just do A, B, C, D, exactly. Yeah, and I tried to trace graph that. It didn't.
It's not useful
very-
because it's internal code.
Yeah.
All right, let's zoom back out again. But by the way, look, one conclusion is we need to make string diagrams be a, something like string diagrams, our version of string diagrams, which is basically graphical variable knitting, the graphical generalization of composition, which again is surely related to directed acyclic evaluate. Could you put in Zoom chat, could you put the link to directed acyclic evaluate? Brad. Hello, Brad. Or anybody else? Somebody put the link to direct. Thank you. That is not a good basic example. Look at how complicated that is. What is a minimal example of this? I mean, you're taking a graph, and just like with treefold, where you are, am I right? Can you say?
The basic minimal example is just that path count is linear recurrence. And so we make these graphs where basically it's just doing that one's the Fibonacci sequence.
Okay.
And that's really that graph that's specified there is one of the simplest easy graphs. I mean, if it was just a straight path graph, nothing.
Okay, but this function, if it was, the correct design would surely be, you feed it. I don't understand. You feed it a graph and the rules. And what does it output? It outputs tagging on the graph, right? It outputs a value. So what this is, just like our trees have payloads at every node, right? We do not currently have a payloaded graph. Does that make sense?
But we do have the vertex weights that we can.
I understand that. I understand. So we can, but we don't have something which is a payload first. I mean, trees are a very payload first kind of structure. But we can imagine a graph. Okay, so this is a case. Okay, what is the relationship between this thing, which is, oh my gosh, the at every step, it is going to one new node. Is that correct? No, no, this function takes all kinds of hair.
When it's, this is kind of like a rough draft, honestly. It worked for what it was meant to do, but in the next version, what it probably will do is step through levels of the foliation of the directed acyclic graph.
Okay, which is deeply related to something you weren't, okay, what is this? So Ian is sending us.
This is an identity between treefold and directed acyclic evaluate. So directed acyclic evaluate is starting from all of the roots of a graph. Like in a DAG, you can have more than one initial vertex, right?
Yes.
And you're accumulating a value down to all of the sinks or whatever, all of the leaves, right? And there's a slightly different syntax from treefold, but so there's.
But so wait a minute. So are you saying that you can sort of from a DAG, you can construct a tree. I mean, a DAG can be unrolled in a tree, but
So this
in
is like
ways.
This is like restricting directed acyclic evaluate to trees.
I see. Okay. Okay, fine. Yes, I understand that. So it has multiple roots in general.
Mm-hmm. So in tree 2, 4, 5, 6, and 7 are the leaves. Directed acyclic evaluate. In order to get this to line up, you have to reverse graph of the tree because those are
whatever. Yeah. Whatever. But I see the correspondence. But I mean, and the main point here is this concept of a graph with payloads, which seems to be very related to string diagrams. Is that true? In other words,
and you also need ports.
Right. Okay. So what we don't have here is graphs with payloads, and yes, we do partially have that through vertex weights, and with ports. Right, where and string diagrams, obviously, as in Nick's picture, have ports. I mean, that's the whole idea. Those tensor indices there. Now, as I recall, in the Penrose tensor notation, aren't there elaborate ways of indicating symmetry between those different edges? Jose, maybe you can say, or somebody else.
Yes, there are. So depending on if you can say have an object that is symmetric under swapping of two indices, then you assign a shape to that object that is symmetric.
I see.
Right. So so it's important to have ways of identifying which port is the first one and which one is the second one.
Unless it happens to be symmetric, in which case it doesn't actually matter.
Exactly. And then you want a shape that hides which one is the first and the second.
And what is that shape?
I don't know. For example, imagine that something that is fully symmetric. All of them are equivalent. Then you want something like a circle, because it doesn't matter which one is the first.
Oh, you mean that you draw this diagram, instead of drawing that as a box, you draw it as a circle where those connectors come onto the circle.
Exactly. For example, in this case, in which the left shape is different than the right shape, is some sort of trapezoid, you have a way of orienting yourself. So you always know which one is which one.
Yeah, there's some interplay with shapes here, because if you make this in unsymmetric shape, there's a meaning what it means to transpose this tensor to make an adjoint of tensor. It's basically flipping around the shape, either in the horizontal or vertical axis, or just rotating it.
Okay, but the main thing is the concept of the disembodied evaluation. The disembodied, we shouldn't call it evaluation graph. The disembodied kind of function knitting graph. And Seth is commenting that directed acyclic evaluate might be useful for probabilistic graphical models, which are important in causal inference. Yeah, I mean, we keep on looking at things like this. After I did that big long discussion with Judea Pearl, we looked at this even some more. There's a whole bunch of ideas that are connected. This probabilistic graphical models is, I think, what we have with things like token event graphs and causal graphs and so on are much more industrial scale versions of the same type of idea, where, in probabilistic graphical models, every what we would call event has a name and a significance. It has it's a thing, like it's, some thing you identify in the world, whereas we have these much more industrial scale things where we're generating giant causal graphs and so on. But I think it's the same type of idea. And I think, yes, it's true that some evaluation of causal graphs is going to be the same type of story. All right, let's return to I want to make sure that we have this we have this way. I mean, again, we're going to need this whole discussion, graphs with payloads and ports. I think that probably should be broken off as a separate discussion. And then once we have that, the notion of sort of evaluating a graph, which is closely related to directed acyclic evaluate, becomes something we should talk about. Okay, let's go back to our naming problem here of this is a splitting. See, I don't know what the metaphor is. Come on, guys, we got to be able to do this. What is the right kind of concept metaphor? You've got two functions to be applied to one thing.
What about the name map into for the version that takes a level spec? I put some code in chat.
Forget the level spec. The level spec is yet another, bizarre and complicated
Well,
thing.
as opposed to the version that's like construct. The Varargs version, I think, if we had a Varargs version, it would need a different name, I think.
Yes.
I mean, not just like if we had both of them, it would be different. I mean, if that was the version we were going with, we would name it differently.
What the heck is going on here? This has its arguments in the opposite order.
Yeah. So this has the arguments in the same order as map.
No, it doesn't.
Well,
map
it
into
doesn't. It doesn't.
the original
That-
proposal.
I think it does in the sense that the list is in the second argument, but it doesn't in the sense that the functions go in the first argument of map. So it depends on which one of those you take to be the
Yeah,
important
I think
one.
the function
Right.
should be.
So the idea
plus.
of this is that you're mapping something into the sub-expressions rather than around the sub-expressions, which is what map does.
Yeah, I mean, it
Clever,
does
but
make a certain amount of
incomprehensible.
sense. I'm not sure I agree it's superior, but it's not a priority obvious to me that it isn't superior.
Okay, what are we really doing? What we're really doing is we're taking a list of functions and applying them to an argument. I'm sure we've had apply list before.
Right. And I think the main argument against this is that this isn't apply in the sense of
know.
apply. And since this is something that's so closely to the map apply family, that's a potential issue.
How about map functions?
Say it again.
Map functions with an S on the end.
It isn't a map either. There's nothing mappy about it, really.
Well, it's mapping the
Well,
functions. It's not mapping over values.
Yeah.
Oh, that required too much explanation, I think.
I mean, I think map is the most analogous function. Especially when
It
you
is,
consider
yes.
the behavior like where instead of giving a list of F and G, you give some other thing,
No, I agree with
H of
that.
F and G.
It's reversed map.
Right. This is why someone made the joke the other day that we should call it Pam for that reason.
Yes.
I like it.
I think that was me. Yeah.
Can the P
next
be
we'll have
lowercase?
next we'll have car and cutter.
Yeah. Okay.
I
Okay.
also like the idea of a variant of map. And I think I suggested long ago dual map or co-map, but you found them too mathematical. The co-map idea is related to what Nick was saying before.
Mhm.
So this is some sort of covariant version.
Do you think anybody would understand that? I mean, it's one of these things where we get the opportunity to educate people about a small number of concepts. Do we want to pick this one as one of them?
So I think I would use it with lowercase m. And I mean, I'm thinking about map. A map is a name that we have learned to interpret.
I agree.
So either we find a variant or a completely different name or a combination of two functions that imitate this one. But all possibilities like through construct is very complicated.
Right. I mean, I suppose given that one implementation is literally map of construct, right? We could call it map construct, but I don't know that actually helps anything.
I don't think it helps anything. I mean, it's Do we think comap versus dual map?
I mean, maybe dual map. I think.
Although dual map sounds like it's doing two maps at once.
Yeah.
Yeah, I thought about multi-map, but I think that's also
No, we don't want
not
to touch the
right.
multifamily.
Right.
I kind of like comap.
With or without the capital M?
Tragically without the capital M. I think it looks too weird with the capital M. And co doesn't mean anything on its own.
Mm-hmm.
Yeah, but comap has a certain, I don't know why, but it's just a very weird word. It's kind of,
It's not obvious how to read it even.
no, com AP.
Anti-map?
Reverse map. It's not right.
Yeah, I suggested that a few minutes ago.
Anti-map just seems crazy. I mean, the
Contra map.
that
Just
actually might
if
be
we're
better.
talking about Latin prefixes.
Well,
But then
just
we're gonna have
wait until we do
comap
the
and contra map, and then we're gonna have to be,
Yeah.
right.
I thought you said counter map, which is not
There's
quite.
another good Latin derived one.
Who would ever understand this? The one sentence description of this thing. Look, the one sentence description is, blah, blah, blah of FG, comma, X. This is how we describe it. Gives, F of X, G of X.
Right. I mean, I think if this was in version 1, this would probably have some weird name like a cross or something. Like it would just pick some verb or preposition or something. But honestly, I think that's, a lot of those names like through are not good names because it's just totally indecipherable.
Apply across. That has the apply
But
problem again.
when we're adding apply, the apply actually means nothing. It's just that there's function application involved, which is the case with almost all of these functions.
Construct across.
What?
Construct list.
Again, no, this.
It doesn't return
If we're
list.
having the version that isn't varargs, I think construct is misleading.
Oh, yes.
I mean, probably, yeah.
God, I can't believe we spent
What
another.
about thread heads?
So the thing I would expect thread heads to be is exactly through,
Yeah,
which is
exactly.
that, I have it
Got-
as the head. Yeah.
Right. Yeah, that's what we should. All right, so we rename through thread heads and we make through be this function.
Well, would through even be the right name for this function?
Probably.
No, through is the wrong name for everything. Like it's a useless name.
All right. What would you expect to see?
What do you think of the proposed usage message I put in chat?
Oh, wait a minute. We've got a bunch of other suggestions people were not making verbally, like map first.
Sounds a bit
At
like
first is
select
completely
first.
wrong. Right. Yeah, exactly. That sounds like select first.
I do like CoMap.
Right. I guess one question we haven't explicitly discussed is, does the first argument have to be a list, or can it be any?
No.
Okay.
So if it's a different wrapper, it returns that wrapper again.
Yep.
Right. Same semantics as map, and also the same as through, except that you don't have to apply the object. Which means you can do nice things, like if you give an association, through can't work with an association because the moment you apply it, it'll run.
So in this case, you're saying that CoMap could take an association as the first argument, and then this will, so wait a second. So what does this do? If we say map, I can't even remember what we called it here, HeadMap of an association, A goes to X, B goes to Y, and we are...
And give it 2, then you'll get the association A goes to. Oh yeah, that even
that's
works.
the right
Yep.
thing.
That's the correct thing.
God, I need to understand this. What is this doing now? So
It's
this
just taking
is,
the X and it's
Yeah,
applying
okay.
it to 2, and it's taking the Y and it's applying it to 2.
Right, because it's taking all the elements at the first level of the association, right? Because that rule isn't really there. It's that, right? It's just.
yeah, right.
So the thing to do to do a practical case, just write this. Just instead of A, write quotes mean, and for the function write mean, or like average goes to mean, and variance goes to standard deviation or whatever.
Now what's annoying is if we don't have the varargs case, then if 2 is a list, this wouldn't work.
No, but then what you can do
It'd
is
be
you
to
can
double
do,
wrap list, right?
well, no. If we don't have the varargs case, the list will just be fed in exactly like it is here. And if you want to do the kind of varargs behavior, you just map apply over your association here.
What? You'd have to, but I don't
we-
understand
So-
that.
If we
Right, then
don't have
do
the varargs
apply-
case,
apply
then this
flash
wouldn't
at-
work as it is, right?
There's an example
no.
if you open the level spec section right below this.
Yeah, the head, that last example with the head map.
See, what was I?
Right. So that's how you implement varargs
Right, it
behavior if you don't
turns
actually
each-
have varargs.
That
Right,
wouldn't
it-
really work if you're dealing with stuff that holds code, though. It would be kind of annoying to have to work around that.
Sorry, what do you mean stuff that holds
So the
code?
operator form of apply, I mean, let's say apply of hold form, right? You can't take that operator form and then apply it to 1 + 1 and get hold form of 1 + 1. It'll evaluate.
Well, but head map already doesn't have, already doesn't have attributes like that, right? So
Well, yeah, but I mean, you can always pass unevaluated stuff to functions like this. So you can, you can pass unevaluated to map, or whatever, but once you're dealing with that operator form, that's not going to work anymore.
Yeah. Then you would have to map function across your thing and give it the appropriate attributes.
Yeah,
Yeah.
and that's the part that
but
would
that
get
is
very
kind of
tedious.
painful.
Maybe there should be a separate CoMap thread that's like map thread.
Yes. I mean, if we're going with CoMap, okay, so we've got CoMap. I'm beginning to like this. CoMap of FGX. Okay, and then we'd have CoMap thread.
Which is just the
would
kind
be-
of
Which
varargs
presumably takes
version.
a list in the second argument, like map thread does.
Right. Which then turns this into f of x, comma y, comma g of x, comma y. Right? I mean, this is just...
Is it just doing an outer then?
No, it's doing yeah, I guess.
I mean, really what this is, as you've been saying, is apply f, apply g, co-mapped onto that.
Right. And the only cases where it's not equivalent are when, I guess, when you use unevaluated. I mean, I can't really think of any other cases.
Well, so if the first argument had like the head hold, then you'd be co-mapping a literal apply of F, and it wouldn't evaluate because of the hold.
No, but again, there needs to be an unevaluated in the second argument for that to make any difference, right? Because otherwise the second argument is going to evaluate anyway, and so it doesn't matter, if the
Right,
doesn't
but the
matter
apply
how it
still
applies.
will evaluate, regardless of if there's an unevaluated for the second argument.
Sorry, what was that? I didn't hear all of it.
Type co-map of hold of F comma G.
Or maybe HeadMap so that we can see what it does.
Sure.
No list though.
Comma 2. Just no list inside the hold.
Yeah.
Well, that's an implementation.
Yeah.
So my point is, if let's say you fix the implementation, still, if you had apply of F and apply of G, you'd have a literal apply of F there. Still, it's not going to immediately evaluate the function.
Yeah. Look, if we're going to call it co-map, it's got to have the same argument structure as map with level specs, which then probably means a co-map thread has to be there.
I want to think about whether thread is the right name though, because thread kind of implies you have two parallel lists, but I don't think there are any parallel lists involved.
Well, what about co-map apply?
Yeah, that seems like
Yeah, I think that's a better name. And is this the equivalent of map apply? Is this the dual of map apply?
That sounds reasonable.
Well, so map apply will do that. Okay, let me just understand. If you say, we used to saying map F over the list ABC. So we would now say co-map the list FG over X.
Right. And then we can confusingly have the infix of /@ or at / or something. I'm kidding. Don't do that.
or maybe it's co-map X under list FG instead of over.
You mean that you state the arguments in different order, even though
no, he's just suggesting that in the informal description, rather than saying you co-map FG over X, you would say you co-map FG under X, because we're now in the opposite.
Sorry.
Say that again. What why is FG
map
under?
You map
under G?
You map functions over arguments, but you co-map,
X
functions under arguments. Because up is down, because it's co.
Yeah, I know. All right, we should wrap up here. I think we let us proceed with co-map and co-map apply and see.
Right, and actually, it does seem like co-map apply is really the dual of map apply, because it's the same concept, but instead of the list being around all the different sets of arguments, it's just around all the different functions.
Okay.
As someone who understands map apply going to agree or disagree?
Well, it's not clear to me what we've decided on the argument structure of co-map apply. Okay, so that's list FG,
comma the list, it's the equivalent of map apply onto F and G, except that it deals with the holding correctly and so on.
Mm-hmm.
Right, and no level spec.
Yeah. Right. So
apply.
so I think co-map apply. Yes, then I agree with Christopher's assessment,
which does encourage the name co-map. in mathematics, when we say there's a mapping, and it's a little weird. This is a little different, yet again, than the mathematical meaning of a mapping. Not that map is the most spectacular, mathematical mapping thing.
Right. Is there a, I mean, there must be some area of math where there's a concept of a co-map.
I'm sure there is. If not,
I mean, sometimes the inverse map is referred to as the co-map, right? Especially when you view it as going, to sets, right?
It's a cofunctor. There's a cofunctor.
Yeah.
It's usually map is a functor thing.
Right.
But the notion of a cofunctor does exist, right?
Absolutely.
Well, then it's probably the right thing.
There is a thing called comap in Haskell, apparently.
Which does what?
Well, usually
Give me
if
a
you
minute.
have 4 in Haskell, it means that there's arrows reversed.
Yeah, actually, I think comap is just basically the functor map. It's just map. I don't know why they. Yeah.
All right, we should wrap up here. Thanks a lot, everybody, and see you all soon.